Hello, everybody. Welcome back for another video. This time we're going to be learning about regressional analyses. Now, just jumping right into things. Up front with this video, one thing I'd like to say is the video will not focus on conducting and interpreting regression, but rather this is just a brief introduction and overview as to why it matters, why it's important, and why researchers might ever want to learn more about it. So if you'd like to learn more about how to actually do and understand what regression's telling you, I will probably have another video for you soon that you can check out to see that. For now, though, let's jump in and look at our agenda for this video. So with this introductory video, there's two big things that I would like to cover. One, what regression is at its basic level and why it's useful for a researcher to know it and want to learn more about it. And two, I want to overview just a few of the types of regression that are out there that are pretty useful for researchers that can help them conduct better studies and data analyses overall. And so jumping forward, let's figure out what regression is. So regression analyses, if you remember, I had given this little brief overview, this table in our correlation video about all the dots and how we can start to see patterns in the dots. Well, with correlations, we can see that the dots are in a pattern, but regression, what it allows us to do is take the pattern and predict how a future pattern in a different study or a different year or a different sample of findings would ultimately behave. So whereas correlation ends up being our spread of the dots, one-time case, regression ends up being the line that we draw that tells us how the dots should function if we were to do this again in the future. Regression allows us to predict things. And it does that because it basically creates an equation through the data. So whereas correlation, we got our little r, if you remember that from the last video, our little correlation coefficient. Well, regression takes things one step farther and says, well, we have all this data. Let's generate an entire equation that allows us to predict what will happen if we got similar data in the future based off these findings we have. And so this little equation here, said simply, it's the line that we saw on that last slide. It creates this line of expectation based off current findings. Now, why do we want an equation? This seems like it's getting a little heavy, right? Well, it's really not too bad once you understand how things are working, as well as you start to see some of the benefits of having this line. Again, I keep using the word prediction, but having an equation means where we have an X up here and a Y, you can put numbers into your X, Y. So going back to that first slide that I had here, if we wanted to know how much video games versus reading versus TV time impacted how much intelligence somebody had over, X weeks of studying or playing or reading or watching, well, all we need to do for each of those is put in some new values for the X here, and all of a sudden we start seeing just how quote unquote intelligent each of those different entertainment forms might have on a person. So prediction's a powerful reason to step up into regression analyses. Rate of change, we also get to see how much one variable might impact another. So for the sake of simplicity today, we're going to call it the slope. But again, jumping back to our previous line there, you can see that these slopes are not created equally. So for instance, our video game one here, it's growing positively. Our reading one ends up growing positively as well, but the shape's not the same as the video game one. And our TV time, both going down and going down pretty steep, the slope of that line, the angle of it, we can gain from having this equation. And lastly, our intercept, if we treat x as 0, in other words, not having watched TV, not having watched, played video games, not read a book, we can understand what our rough y estimate is, this right here, where it should start if the x that we are studying hadn't been implemented just yet, which is another valuable bit of information when making predictions about future choices. For instance, changing things in a company or selling this product or moving this color here. These are some pretty big benefits. Now, one more that I'd like to bring up is this right here. Regression allows us to also examine multiple variables at the same time. So from the correlation video, you might remember that I had originally proposed, what if we wanted to study how much video game playtime is related to a person's intelligence in a class? Well, that's one set of variables, but maybe we'd be interested in knowing if reading books compared to video games, one of these led to more intelligence overall. In a correlational analysis, for the most part, without some extra steps, we can't really do that simply. But with regression, we can plug it all into one model and get several different variables being predicted against each other at the same time, which is a huge benefit compared to some of our other analysis types that we've looked at so far. So one other thing I'd like to mention before moving on to the different types of regression is just a friendly reminder of what kind of data level that we need to be able to conduct such an analysis. Well, with regression, similar to correlation, we need to have interval to ratio level data. So I've got these exact same categories from the last video. Yep, they're all the same. Your age and your speed, your weight and your ounces of soft drink, your hours of sleep and your class grade percentage. All of those are something that we could calculate at the interval or ratio level. However, color of a laptop and how well a person's doing in class, or whether they're a freshman, sophomore, junior, senior, that's not quite how these analyses work. Whether or not you have a blue laptop versus a green laptop doesn't really tell us how well you might be doing in a class or what year in school you might be. That categorical data does not work in regression analysis. So with that being said, let's look at a few different types of regressions that you might be able to perform someday and some of the benefits, uses. Basically, I'm going to use the exact same study that I've been talking about, the same hypothesis that I've been talking about so far, and I'm going to use it just showing us briefly in a bunch of different ways, the same exact ideas, the same variables, but showing you how you could ask different questions with the same variables and get different answers depending on what it is you exactly want to know. So with our types of regression, the first one we're going to cover is what's called multiple regression, which is already what I covered with that first chart of showing the different lines. It's when you create a model that has several predictors in it, several X variables that are being performed simultaneously with one another to see how much they each contribute to the ending Y dependent variable. So said simply, we can look at how much playing video games versus reading a book, how each of these individually lead to classroom intelligence. And so the model would treat both of the variables the same way, and you could see how each of them in comparison to the other would impact the same Y variable differently. But maybe that's not the question you want to answer. So this is one way we could we could look at these variables' relationship to one another. Another way would be, for instance, what we call hierarchical regression, which is when we build a model that controls for past models. So our equation, if we put in an equation for one X variable, for instance, but want to see what a second variable would do when we already have all the results from the first model there. In other words, all the variance, all the differences that had happened in the first model, maybe we want to see what a second variable might do on top of what was already done in the first model. And so to explain that just a little bit differently, maybe we want to see how much video games contributes to intelligence first. But once we have that variance, we see how much the dots had moved in that graph, how much people's responses had varied, and how much intelligence had varied. Well, then, having already got all of our data and numbers for the first model, we basically run the model again, except this time we add in a second variable, in this case, reading time. So we already know how much video games contributed to classroom intelligence. What a hierarchical regression does is allows us to say, well, on top of what was already explained by video game time, how much more can be explained through reading time's contribution to intelligence. In other words, you basically do one model first, and then you stack a second model on top of that to see how much has changed. So that's a different way to answer the same question, looking at them both at the same time versus looking at how they each contribute more variance to a model or a question that we're already exploring. So those are two types of regression. The third one we'll look at is what we call moderation. Okay, and moderation is when we're looking at the relationship between two variables. So again, our video game time on our classroom intelligence, but we consider whether a third variable might change exactly how the relationship between the other two variables happens. So as an example, maybe we find that video game time increases a person's intelligence, comma, but only when that person also reads. In other words, if the person's only playing video games and they don't ever read, maybe their intelligence changes based off when they read as well. So another example, I don't have pictures, but let's say that our X here was how much sunlight a plant gets, right? And Y is how much the plant grows. Well, we know that plants grow with sunlight, right? Except how come my plants keep dying? Oh, yeah, because I forgot to water them. Said simply, how much a plant grows may be related to how much you give it sunlight, but only if it also gets water. In other words, the third variable changes the relationship between the first and the second. That's moderation. Now, one final type of analysis that I want to show you today is what we call mediation, which is, again, our same three variables, but look how we could ask a different question with the same three again. Maybe instead of thinking that the relationship's conditional or that we just look at them each and see what's happening, maybe we want one final approach, which is asking, maybe something to do with X is causing something else to happen. And because that third variable is happening, it's leading to the actual Y variable that we're interested in. So we call this an indirect relationship. Okay, and what that means is that X in and of itself isn't necessarily causing Y. A person's video game time might not be causing their classroom intelligence, but maybe playing video games a lot might cause somebody to also be interested or want to read. Oh, I learned all this stuff in my games. I wonder if it's actually true. So they spend more time reading. And because they're reading, that ultimately leads to their classroom intelligence later. Okay, another example I might give is humor in a classroom. A funny teacher, actually, research tends to suggest, decreases how much students learn in a class because they're focusing more on the funniness and less on the learning principles. However, even though funniness directly might not be causing students to learn more, having a funny teacher might cause students to be more engaged in class, might want to come to class more, might be less scared to ask questions. And because those other variables are happening, they are what are actually helping the students learn more in the classroom. And so this process of X causing M and M causing Y afterward is what we call mediation. So one final thing before we wrap up this video, why we're looking at these different types of regression, and especially those last two, moderation and mediation, which might seem a little more complex than maybe we're used to asking questions in our studies. It's why it's important is ultimately because human beings and all these things that we usually study, they don't work in X to Y relationships. Or said differently, usually it isn't one variable that causes another variable. Playing video games doesn't just make you smarter. Playing video games doesn't just make you more violent. Playing video games doesn't just increase your weight. There's usually third, fourth, fifth, sixth variables that are also being accounted for that help us understand why X and Y are actually related to one another. And unless we ask these better forms of questions, we usually don't actually get the answers to human questions that we oftentimes want, which is why you see research a lot of times struggle with replicating results in future studies, is the original researchers treated X as Y as if they were the answer, and they missed so many of the factors that would change the answer on any given day. And so, yes, this is problematic, this form of researching. We want to look back more at these other versions that we have. Regression is a great step up for a researcher looking to explore more in quantitative research. So putting all this together and wrapping up, regression are great because they allow us to make predictions on data, not just explain or see what's happening with data. We can actually use this data to predict future findings that we might have. Also, we looked at different types of regression and seen why they're important, how they can help us answer the same questions differently depending on what actual questions we have. Hopefully this helps get you excited and maybe want to know a little bit more about regression analysis. And I appreciate your time and watching. Thank you.